Hey there, welcome, or maybe I can say welcome back to this AI-3026 Developing AI Agents in Azure course, where this specific module covers how to develop an AI agent using Azure AI Agent Service. My name is Peter Ditender. I'm a Microsoft technical trainer here at Microsoft for almost 6 years now. My Azure background has always been architecture and DevOps, but I gradually shifted more to app modernization and, no surprise, AI and Copilot solutions for the last 18 months. This module is one of the 5 modules in the course. You can choose to go through all modules or only a few, depending on your needed skills and where you are in your developing AI agents journey. This specific module builds on the concepts from the fundamentals of AI agents discussed before, but really expanding on what makes an AI agent useful, detailing more on where AI Agent Service fits in the broader Azure AI Foundry concepts and architecture. And then in the second half of the module, we'll explore the SDK to chat with our AI agent, closing the module with another live demo and how to develop your AI agent, invoking a chat session with the agent and retrieving chat messages. So with that, I would say, let's learn developing AI agents together. Now, before diving into the actual development process of AI agents in Azure, as developers, we need to think about the purpose of the AI agent, like where and what is the value it brings to the business and to our users. So the main question to answer here is, why are AI agents useful? Honestly, there could be a ton of answers to this question. Now, to me, it comes down to 4 main categories, which works for most AI agent scenarios you might have in mind yourself. The first one is really AI agents being useful for automation of routine tasks. AI agents can handle repetitive and mundane tasks, freeing up human workers to focus on more strategic and creative activities. This leads to increased productivity and efficiency. AI agents are also useful for enhanced decision-making. By processing vast amounts of data and providing insights, AI agents support better decision-making. They can analyze trends, predict outcomes, and offer recommendations based on real-time data. AI agents can even use advanced decision-making algorithms and machine learning models to analyze data and make informed decisions autonomously. This allows them to handle complex scenarios and provide actionable insights, whereas generative AI chat models primarily focus on generating text-based response. Another great characteristic of AI agents is scalability. AI agents can scale operations without the need for proportional increases in human resources. This is super beneficial for businesses looking to grow without significantly increasing operational costs. And then last, AI agents provide 24/7 availability. Like almost all software, AI agents can operate continuously without breaks, ensuring that tasks are completed promptly and customer service is available around the clock. More below here on the slide, you can see several use case examples of AI agents, as we also already highlighted in the foundational module around AI agents earlier. Note that in reality, there is basically no limit to what kind of AI agent you would develop. I would say use your imagination. Now, Azure AI Agent Service is that fully managed and designed to help developers build agents without having to worry about underlying resources. Through Azure, AI Foundry and the Agent Service will provision the necessary cloud resources. If desired, you can choose to connect other Azure resources, such as Key Vault to store secrets, Azure AI Search to build RAG solutions, connecting to Azure storage accounts, using them as a data source, and why not interconnecting with other AI services already available in Azure. As you can see, your AI agent within Azure AI Foundry nicely integrates with your other Azure resources and workloads, giving you the flexibility to utilize Azure however it works best for your organization scenarios. Now, at a minimum, you need to create what we call an Azure AI Hub together with an Azure AI project. From there, you're going to allocate your agent. You can create the resources using the Azure AI Foundry portal, or you can use predefined Bicep or Terraform templates to deploy the resources within your subscription. Depending on your development background, you might already have developed agent-alike solutions in the past, long before we even talked about generative AI or even before Azure AI Agent Service existed. But this typically required an extensive set of code, especially to provide data grounding or connecting your agent to custom solutions. The Azure AI Agent Service simplifies a lot of all that. With just a few lines of code, your AI agent can connect to Azure Functions or integrate with OpenAI. Azure AI Agent Service provides several SDKs as well as a REST API for you to integrate agents into your application. On top of that, using your preferred programming language. The demo I'll do later in this module focuses on Python, but the overall pattern is the same for REST or when using other language SDKs. The diagram here shows the following high-level steps that you must implement within your code. Connect to the AI Foundry project for your agent using the project connection string and Entra ID authentication. Next, get a reference to an existing agent that you already created in the Azure AI Foundry portal, or why not create a new one? From there, you're going to create a thread for that chat session with the agent. Remember from the fundamentals module in this course that all conversations with an agent are conducted on a stateful thread that retains message history and data artifacts generated during that chat conversation. From there, you're going to start the actual chat-like conversation and add messages to the thread and invoke it with the agent. You can check the thread status and, when ready, retrieve the messages and data artifacts. You're going to basically repeat the previous two steps as a chat loop until the conversation can be concluded. And then eventually, when finished, delete the agent and the thread to clean up your resources and also delete the data that is no longer required. Now, much of the enhanced functionality of an agent comes from the agent's ability to determine when and how to use tools. Tools make additional functionality available to your agent, and if the conversation or task warrants the use of one or more of those tools, the agent calls that tool and handles the response. You can assign tools when creating an agent in the Azure AI Foundry portal, or when defining an agent in code using your preferred SDK. For example, one of the tools available is the code interpreter. This tool enables your agent to run custom code it writes to achieve something, such as MATLAB code to create a graph or solve a data analytics problem. As discussed before, AI agents have two categories of tools available: knowledge tools and action tools. Knowledge tools enhance the context or knowledge of your agent, where you can see a list of such examples here. For instance, Bing Search, Azure AI Search, or using Microsoft Fabric, to name just a few. Action tools, on the other side, perform, you guessed it right, an action, or they can run a function. Some examples listed here are again the code interpreter, Azure Functions, or for instance, the Open API spec, allowing for calling external APIs. So now it's your opportunity to follow me again in building an AI agent in Azure AI Foundry. In this specific demo, I'll show you how to create an agent and test it using the Agent Playground. I will then develop a custom app that integrates with an AI agent through Azure AI Agent Service. Now, the starting point here is creating an Azure AI Foundry project. So I would say let's get on with that. Now, as you can see here, I'm in my traditional good old Azure portal, where in my default view, it shows me the resource groups. Now, there's a couple of different ways to actually create an Azure AI Foundry project. You could look at it from an Azure resource perspective, but it's so much easier if you go straight into the Azure AI Foundry portal. So you connect to ai.azure.com. You're going to provide your Azure admin credentials, and from there, we're going to create a new project. So I select Create Project and just following the pre-built wizard. Now, there's a few things I want to highlight and customizing for my demo setup a little bit. What I mean by that is the default project name. Now, obviously, we want to make sure that our naming conventions that we have within our organization are not only followed for actual Azure resources, but also for our AI Foundry project resources that we need to create. So to keep it a bit consistent with our training, I'm going to call this the AI-3026 demo. And since it's a project, let's call it a demo project. I could accept all default Azure resources getting created, which means it's pointing to my subscription. It's going to create a new resource group in a specific location. And obviously you can change all this. It's going to create a hub, a data store, and it allows for now public network access. Now, again, I'm pretty okay with all these settings for my demo setup. But if you have any specific Azure policies in place, or you got certain regulations to follow for your eventually production environments, then obviously I would say keep an eye on those because they might be totally different for your setup. Now, although I'm fine with the suggestions, I'm still going to make it a little bit more straightforward and at the same time using this to help you understanding a bit like what's happening behind the scenes. You already know I like changing the default naming conventions a little bit, and I'm going to do the same here. So I had my AI-3026 demo project, and it belongs to the demo hub. Now, in the presentation, later on, we're going to talk a bit more about hubs and projects, but in short, it's really the topology that AI Foundry is using for all projects within. Already okay with my subscription, and I'm going to use a new resource group, and let's call this one my demo RG. The location itself, you're pretty flexible on this, but at the same time, knowing that later on we're going to deploy some other Azure AI resources, I would say to make sure that everything works as smooth as possible. Not all models that we're going to deploy as part of the different demos are available across all Azure regions. So if you're following along using my demo scenario as a little exercise on your end, I would say it's pretty safe to use East US 2, Sweden Central for the EMEA region, and then also West US and West US 3. So I'm going to keep my East US 2, and I'm not creating any integration with Azure AI Search. From here, we click Next, Create, and it's just going to take a couple of minutes typically to create all these resources. Now, at the same time, I started from the Azure AI Foundry portal. If you go like, well, my environment is typically relying on infrastructure as code, like using Bicep or Terraform, then obviously you don't have to go through the AI portal first. You would create your resources from an Azure perspective, and then they will show up in the AI Foundry portal as well. So I think from here, since we got redirected after the project setup into the main Azure AI Foundry portal for our specific project, I think we're almost ready. But before jumping into the actual technical demo steps, let me highlight some of the core configuration parameters that could be useful to know where to actually find them. So first we have our project up here, and you can see it from here, which means if you have multiple projects, you could easily switch across all of these. Next to that, at some point, if you're going to start building your AI agents, which again is the core of this course, it's going to ask you for that project connection string. That's really what your agent needs to interact with your AI services. So in meantime, you know where to find it. Now, although it started with creating our AI Foundry hub and project, at the same time, it's also creating our resource group. And from here, and I still think this is pretty nice, it's also automatically creating all the core building blocks or Azure resources that we need for a decent end-to-end full Azure AI project. Now, before we can dive into the actual developing agent story, we need to add yet another component into the topology. What I'm talking about is deploying a generative AI model. Now, again, there's a few different ways here in AI Foundry to do that. You could go into the top level, selecting model catalog, and from there, you're going to get access to, I think, close to 1,800 different models to choose from. What I'm going to do is working with my assets. Now, technically, there is no difference. It's just, I would say, this is my project. These are my assets. That's the logic behind it. I'm going to use my GPT-4o model. And again, this all depends on the functionality you want to build in to your agent. I select my list of models. I'm going to filter for GPT-4o. We got a lot of different options here, but I'm going to use the baseline. And I need to complete some additional settings. Now, all depending on the details of your setup, you might just hit deploy and everything's getting deployed for you, or you might need to define some customizations. What I mean by that is, for example, the deployment name. This is something rather unique for this specific model deployment. I like to use the same naming just to make it a little bit clear later on in our actual development code, that if I'm targeting my project with my model GPT-4o, that I don't have to think about my deployment name too much, but feel free to make any changes into that. Another point that I want to highlight is the customization of this model. There's a lot of details why or why not you should make those changes. What I want to highlight here is the tokens per minute, because that's really, in generative AI terms, the virtual currency, you could say, which means that the more you're going to move this to the right-hand side, the more tokens you're going to have per minute, but it might also end up in becoming more expensive. And again, all depends on the use case of your agent. So for now, I'm just going to accept all the defaults and hitting deploy. So as a little recap, we have our AI Foundry portal, ai.azure.com. From there, I created a project belonging to the hub, creating my default AI Foundry topology. And then from there, it's creating all the necessary Azure resources in the backend. And then last, moving into the model catalog and deploying our GPT-4 model. This is, to me, what I call my baseline Azure AI Services setup. So with the baseline setup of our Azure AI Foundry and the belonging services, we can move on with the actual step. And in this case, it means creating our AI agent. Now, to help you a bit, again, my assumption is that a lot of you, although just not watching just the demo, but actually wanted to follow along and turning this into your own little project. And that's also where our Learn resources can actually be of assistance. Now, knowing that this is targeting developers, DevOps engineers, and basically anyone who wants to learn more about AI agents, I think it could be beneficial to make this as platform independent as possible. What I mean by that is, instead of shifting to a development environment like Visual Studio Code or Visual Studio or any other development platform you use, I'm going to try and run all my demos from within the Azure environment itself. What I mean is, I'm going to use my Azure Cloud Shell to actually help me with all this. Now, there's a few different ways, depending on your experience in Azure. It might be totally new. So what I did is clicking this little shell icon here, where technically we actually offer two different shell environments. One is Bash, as you can see here. The one that's currently starting up is PowerShell. So depending on the preferred language or scripting language, you could actually use one or the other. In my case, I'm going to stay within the PowerShell environment. I could move this window around a little bit, but another little cool trick is directly connecting to shell.azure.com. And that's going to allow me to, after authenticating, obviously, to now have this full screen view. I can technically close this one, and then I can continue from here. So pretty convenient, full screen. So with that, let's move on to the next step. Oh, before we're going to do that, actually something else that we can do from here is using a stripped down, I have to say, Visual Studio Code environment built into our shell view. Now, to make sure that all that works fine, I need to go back to the classic version. And this is something that you might or might not need to do on your environment. So I would say if later on when I'm running code to launch VS Code inside the PowerShell view shell window, it will actually trigger like, oh, are you using the correct version? And if not, it's actually going to ask you like, hey, do you want to switch? So let's clear my view here a little bit. And again, if you're following along, when you turn this into your little exercise, you can actually do the exact same steps as what I'm doing, because what I'm doing here is clearing any folder on my system that's called AI Agents. It's just clearing up the cache from testing my demos, right? And then I'm going to connect with a Git clone. So basically cloning our Microsoft Learning repo where I'm grabbing the MS Learn AI agents. And I'm going to clone that into a subfolder called AI agents inside my shell. Takes about a second and it's done. Now, since we're here in our second module, it probably makes sense to switch to the second lab. So what it's doing here is now connecting inside the cloned folder, lab files, and I'm inside module number 2, and we're using Python as our sample code language. Next step is inside the Cloud Shell, I'm going to run some Python code to actually install the libraries that we need. So it's going to run Python v and v for creating my environment, like a virtual environment, and we call it lab environment. From there, it's going to trigger a PowerShell script. All works fine because I'm inside the PowerShell view. And then last, I'm going to run pip install, like the Python package manager, if you're not all that familiar with Python, and then loading a few components. The Python.environment Azure identity to allow me to authenticate out of my app into Azure, and then loading the Azure AI projects packages as well. So all that is done, which now means we're going to start developing. What we need to do that is a development environment. And that's where, again, this classic shell is super beneficial, because what I'm going to do is moving into VS Code, running code dot, which means start up VS Code inside this Cloud Shell and open up the current folder. To me, still one of the more or maybe most convenient things inside our Azure environment. Now, if you remember the flow of the presentation a little bit, we created our AI Foundry project, but now we want to build our agent. We already have some sample code for that. And to make sure that everything is working fine, we need to connect our agent into the project. The way to do that is defining a project connection string. So inside my environment, I'm going to open up the agent Python file, where you can see down here, there is a pointer to a couple of different variables. What it needs is the AI project connection string, and next to that, it also needs our AI deployment name. You're not going to hard code this inside your actual Python application here. but we're going to move that into an environment variable file. If you're already familiar with Python development, this all probably makes a lot of sense. So from within our environment file, it's now asking, and these are just placeholders, right? So it's going to ask me here for my project connection string, and it's going to ask me for the model deployment. Now, just to help you a little bit where to find that information, it's not all that hard, but that's easy once you know where to find it. You go back to your AI portal, select your project, go into overview, and I would say that's also why I want to spend a little bit of time on this. Typically, when you see API key, that's where you most probably get tempted like, oh, that's what I need. Or you might be a little bit confused by the terminology and maybe thinking like, oh, I'm connecting to the service, so I'm going to grab this endpoint. But that's not what you need. So what you need is over here, project connection string. Now again, we're dealing with secrets, so make sure that you know what you're doing. But for now, I'm going to copy this over. I go back into my Python environment and I'm going to paste this in here. In the model deployment, that's again where we define the name that we used for our model deployment itself. So in my case, it's GPT-4o. And this is where I mentioned that it could be beneficial to not overcomplicate your deployment names. That's pretty much it from here. Quite important. We're going to save our changes. The easiest is Control S. And from here, we can leave our code environment, but I'm not going to do that. But at least make sure you do Control S to save your changes. The next step is where I would say our actual developing comes in. So in this example, we're using just a little single agent, and guess how it's called? It's called agent.python. Now, I don't like to walk you just through all the settings because what I need to do is obviously copy pasting a few placeholders. And again, just explaining for the ones who are trying to follow the exercise that we have baked in our Learn platform corresponding to these video trainings. So just to help you a little bit, I'm going to move to my full Visual Studio Code environment on my local machine, walking you through an explanation of what each and every snippet of code stands for, and then copy pasting the whole Python file inside Cloud Shell and running my little app from there. So again, I don't want to make this more complex, but I don't want to explain too much code snippets from within Cloud Shell. So I opened up the same cloned Git folder on my local machine. This is Visual Studio Code. If you should not be all that familiar with it. And I'm inside my agent Python file. So to make sure that we can not just talk through what the demo is about, but also clarifying some of the code snippets, that's mainly the goal of the next couple of minutes. Now you already have several placeholders in our sample code. So the first step we need to do is loading our application references. So what this means here is we're going to install, like adding the Python packages for Azure Identity allows me to really hook into Azure using Azure credentials. Next, I'm going to load the Azure AI projects, and we're going to call this the AI project client. And then we're also going to import the AI project models, which allows us to trigger this code interpreter tool that we need a little bit later on. I'm not going to walk you through each and every line of code here. I'm going to highlight some of the more important relevant steps, you could say, what our agent actually needs. So we have our next step, and I'll make it a little bit bigger. There we go. Where now we have a section of code which allows us to connect to the Azure AI Foundry project. So we're going to create a project client. What I'm doing there is calling that AI project client, pulling it in using that connection string variable, defining the credentials to authenticate, like recognizing the connection string to connect to our AI service, and then from there connecting it to the project client. So in short, the code connects to the Azure AI Foundry project using the Azure credentials that we provide out of that connection string. And then using that with project client, that statement starts the code block that's following a little bit more below. And that's actually defining the scope of the client, ensuring that it also gets cleaned up. The next section is where we're going to upload some data. So it's this little section here, upload the data file and create that interpreter tool. So it's going to connect to our project client. From there, it's going to upload the file name and it's going to trigger the agent to run that code interpreter. And then obviously using the file as a reference point. The next code section is where we're going to actually define the agent. So what it's doing here is calling that agent method, line 51 here, using the project client object, creating a new agent where it's connecting to our deployed model GPT-4o. We give it a name and we provide instructions. Now, if you already had some experience with interacting with Azure AI services, you might remember an object or a configuration parameter called system message. The system message is where you're going to define, hey, my dear AI service, this is the purpose I want you to have. So in this case, we're no longer calling it system message, but we call it instructions. Remember, if you watched the previous module and my demo, this is where inside the AI Foundry portal, I was pasting in the purpose of my environment. And then from there, actually explaining like, hey, this is what I want you to do, using it from within the AI Foundry portal. And now we're moving all that behavior into some code language. So we're defining here that it's an AI agent that's going to analyze some data. Nothing too hard, nothing too difficult. We're almost there, but remember from the presentation, we need to define a thread as well. Where this thread is code-wise defined like this, the thread object equals my project client, where it's pulling in that agent method, and from there we're going to call a create thread step. I'm going to send a prompt to the agent that's happening over here. And what it means is I'm going to create this new object called message, where the message obviously transforms to the prompt, connect to the agent, create the message using the thread ID. The role is user, which means you're not the system agent backend. You're basically the user starting that interaction. And I'm going to use the user prompt to do that. And then we're almost there. But we also need to do some error trapping or capturing, right? And that's where I'm going to move this down a little bit. That's where over here, we're going to check like if there's anything wrong with the runtime, meaning our agent is not really doing what we're expecting. It's going to provide us with some basic error message. Next to that, we have the show latest response. So this is where we build up our history. Remember that our thread ID can be used for that. We have all our chat going back and forth, conversational messages, and we can basically keep referring to them. We're going to generate a file, and then all the way at the end, as we explained in the presentation, we're also going to clean up our environment. So that's basically all we need to run our scenario. So in short, what we did here, just making sure that you know what all the code snippets are doing. We connected to the AI Foundry project. We're going to upload the data file. That's going to create a code interpreter tool and then allowing us to access it. It's creating a new agent using that code interpreter tool, and that has explicit instructions to analyze the data based on the instructions we provided. We're going to run a thread with a prompt message. We're going to check the status, retrieving the message, and eventually displaying the conversation history. From there, it's going to save a file, and that allows us to actually download and looking at the outcome of that. So again, I'm not running everything from here, but I'm going to grab the full code and I'm going to switch back to my Cloud Shell. Again, you don't have to run it from here, obviously. You could actually run all this from within your local machine. But again, I don't want to give you the wrong impression that you need to use Visual Studio Code to do all this. And again, maybe you're just following along as an exercise where now you could actually do this just from within a browser. So I copied over all my code. And what I need to do from here, which might be a little bit surprising, is authenticating. Why? Because we're now running that app, and for some reason, we need to authenticate once more. So I'm going to close my VS Code, and I'm going to run AZ login. Now, by design, and this is already on screen, Cloud Shell is automatically authenticated using your admin user account. Now, to run our application from within Cloud Shell, which might not be the real best use case scenario, but it actually works out fine, we need to authenticate again. This is running what we call device login. So I need to open up a new browser window and providing that device key, where now it's going to ask me for my actual Azure admin credentials. The best practice here is obviously using multi-factor authentication, what we're doing here within our Microsoft subscriptions as well. And I can only hope it's the same on your end, where after authenticating and obviously confirming that it was me triggering that step, it's going to allow me to actually run my code. I'm first going to clear my screen again to not get distracted with all that message information. And from here, I'm going to run my little app where again we use Python and it's called Agent. What it's doing here is now providing some information. So I'm going to give it a little bit of time. And after a while, it should actually ask me for a prompt. Like we got some information, we got category, we got costs. Remember, we're building our little expense tool, right? So the information out of data.txt is now recognized inside our agent or recognized by the agent. And it's going to ask for a prompt like, hey, what do you want me to do? Me being this expense agent. The most easy prompt I could come up with is, what is the category with the highest cost? Like the most expensive item, right? And then hopefully from here, it's going to provide a nice response. For now here, it tells me like, oh, pretty cool. The category with the highest cost, let me highlight it for you over here. Category with the highest cost is transportation, and it also shows me the actual cost item. You might validate this obviously yourself, but I think we can all agree up here based on the little subset of data we have that indeed the highest cost is indeed transportation. You know already that in like a generative AI setup, like a chat-alike scenario, we like follow-up questions and really having that conversational context. So I could run another prompt. I'm just going to paste it in here. Create a pie chart showing cost by category. Why is this so cool? Because what we can do from here, just out of your terminal or out of, in this case, the Cloud Shell, it's now analyzing the information in our data endpoint, and it allows me to create a little image file out of that. I'm not going to run a prompt anymore from here. So I can exit, and then I can use download pointing to the file name over here. So I'm just going to copy and paste this in. What it's doing is now downloading or allowing me to download the file. I'm going to open the file. And what it did here out of the box is using information from here, my data context, turning it into an okay looking pie chart. That's basically all I wanted to show you in this demo. So in this demo, I used Azure AI Agent Service SDK to create a client application that uses that AI agent. And then from there, the agent uses the built-in code interpreter tool to run dynamic code, allowing me to find information about my data context and then also downloading cool looking images. So with that, let's go back to the presentation and sharing the last couple of words in this module. This brings us to the end of this module, developing an AI agent with Azure AI Agent Service. In this module, you learned about the purpose of AI agents. We discussed the key features of the AI Agent Service within Azure AI Foundry. Next, we discussed the different steps it takes to develop your agent. And then last, I showed you how to integrate your AI agent into an existing application. Thank you for being here with me. Our journey of developing AI agents is not finished yet, as we have a few more mountains to climb. Allow me to invite you to our next module, where I'll detail more about integrating custom tools into your agents. I'll see you again soon.